Good morning, everyone. My name is Purya Nikam, as Casey introduced you, and today I will be talking about design and how to design a self-storage center and Steinel's solution for that. Sorry. So a little bit of a background, or just kind of stating the obvious. We usually use two main technologies for detection of movement for the lighting controls purposes. The most common one is the passive infrared technology. The concept is that you have a lens, and you have a pyroelectric element that detects movement of basically it sees heat sources. So combination of this lens and this pyroelectric element gives you multiple detection zones or detection areas, as you can see on the screen, and then any movement that crosses from one detection zone to the other will create an output signal which tells the sensor that there has been a heating source has moved. And then this will be translated into some sort of action, which in case of lighting control would be turning the lights on, or in case of no reaction after a certain timeout, to turn the lights off. There are three important characteristics of PIR technology. One is that it requires direct line of sight. So PIR is looking for the infrared signature of a heat source, like a human body or basically any kind of any moving object. It gives us the possibility to crop and limit the coverage pattern by limiting the view of the lens or the sensor. So basically, if you block the line of sight, you have limited how your sensor works. And of course, it requires the presence of a heat signature in motion for the sensor to detect anything. So any random vibration of like a wall or a glass will not trigger the sensor. The next technology that we are going to talk about is ultrasonic sensors technology. Ultrasonic technology uses sound wave frequencies above human hearing range to detect motion. So what happens is a sound wave is emitted through a transducer or some sort of you can say a speaker into the space, fills up the volume of the space, and then when it bounces back off of the objects, you have another transducer or a microphone, you can say, of sort, that listens to the sound wave that has come back and processes it. If there is a moving object in the environment that causes a Doppler shift in the sound wave, and that's what the sensor is looking for for detection. So it's that Doppler shift that's basically the basis of detection. Couple of main characteristics. Sound waves fill the entire volume of the room, which in turn means you don't need line of sight for the object in motion, because sound waves, basically you're talking about the whole air volume of the room and how it vibrates. And this also means that it doesn't, like, your source of movement doesn't have to have any kind of heat signature. It can be anything at room temperature or at equilibrium with the room temperature that moves or vibrates. So your ceiling tiles, your glass window because an airplane passed by, or anything. And also this gives us the chance to detect very minor motion, which usually cannot be detected by PIR sensors because the motion doesn't cross two detection zones, even if it satisfies all the other requirements of a PIR sensor detection. Now, in the two topics that we are going to talk about today, which are the self-storage centers and data centers, we want to know which technology would be the best solution for these two applications, and then why. Based on our experience, based on Steinel's experience and recommendation, PIR is the right solution for both of these applications. The reason being, in self-storage centers, you have big roll-up doors that anytime there is an air pressure difference because the main door is open, something like the HVAC system in the area has been turned on or off, that would cause all these roll-up doors to vibrate. So obviously it would trigger any ultrasonic sensor that you have in that area, or if an ultrasonic is already on because someone was moving there, it will never go off because of those rattling, and it will always be seen as some sorts of vibration. And also the same roll-up doors, if you open and close them, even that opening and closing may cause the other ones to move and vibrate slightly. So even if you're down one aisle and you open the door, open one of the storage unit doors, it may cause the doors in the other, like the lights in the other areas to turn on, even though no one is there. And in the case of data centers, you have server racks that have very strong cooling fans that basically generate air movement and also cause, like when you have several of these cooling fans on one rack, that whole rack will start to vibrate to some extent. It may not be much for us to notice, but it definitely is not. It definitely is noticeable to the ultrasonic sensor. And of course, the cooling system will take in cool air from one side and blow out warm air from the other side, which would be another problem that we have to deal with, which Kirsten will talk about it in detail. So I will start with the code requirements that we have for our self-storage center. As you can see, I mean, mostly I will be talking about the design in IECC 2015, which is the most common code we have in the country. So the code requirements for the self-storage center would be similar to a hallway or a corridor, with one additional requirement, because they are kind of they kind of fall into the category of warehouse. So you need an occupancy sensor for the automatic all-off. Since these are treated as hallways and a warehouse, they should be automatic on. And then you would need a momentary switch for the manual override of the sensor. And as you can see, you need a PIR sensor that can see. The left image shows it very clearly that you need a sensor that doesn't look in squares, in circles, but actually looks up and down the hallway to give you the best performance with the minimum number of sensors. Here is a little layout, and you can see our recommendation for these for this application is our IS series sensors, which are all PIR. They come in 3 different types: the hallway type, which is IS 345-24, the 360 360-degree type IS3360-24. And for some applications, we have the wall mount 180-degree IS3180-24 version. So for any kind of entrance, as you can see, the red sensor that's shown near the elevator and the janitor's closet and all that, that area doesn't look very much like a hallway, so you can use an IS 3360-24 sensor for those areas. And then anywhere else you have, you can use the sensor that's shown there in the green color, IS 345-24, which is a hallway sensor. So this is where the self-storage center has to follow the warehouse rule, which is each aisle or each hallway should be controlled separately from the other aisles and hallways. So you can't have someone walking down the one hallway causing all the lights in an area to turn on, only in that particular aisle or hallway. So each of our IS 345-24 sensors comes with a little sensor shroud in the box that, again, Thurston will explain it more because it has more application in the data centers of how they look and how to install them. But you can use those to basically cover one side of the IS 345 sensor and make it only look down one side of the aisle. So in case of the sensor that's sort of is the aisle starter on the top of this layout, that sensor will only look to the right down the aisle, and it won't see someone walking up and down the vertical aisle that's shown on the layout. And we also recommend to use our auto-on power packs for the self-storage centers, just to be sure that the switch to turn them to manual on is not changed on the normal power packs we have. So the TR100A is the recommended power pack for self-storage application, at least in the storage area. Sometimes you may have the requirement to put a sensor inside the storage unit. For that application, we would recommend using our HBS 300 sensors that mounts directly to the fixture, and it doesn't require any power pack or any additional wiring, so makes it quite easy, and it gives you great coverage. So one would be more than enough for any storage units that any size storage unit that you may have. And since it's a high bay sensor, it can be mounted at any height pretty much. The other areas, a self-storage center, the main part of it is the self-storage areas, but obviously you may have an office or two, depending on the size of the self-storage center, which follows the same rules that any other office will follow under IECC 2015. So you would need a sensor to have the automatic all-off function. The sensor needs to be set to partial on or manual on to meet the code requirements, and you need to have an override switch. Again, for offices up to 300 square feet, we recommend using our DTWLS DIM or VS DIM, or you can, if it's not a dimming application, you can use the DTWLS 1-W, and just to cover the code requirements in the possible one or two offices you may have in a self-storage center. What you definitely will have in a self-storage center is again, open or small or big reception area where the staff will be sitting. So you have the full code requirement here. You need to have at least one sensor, depending on the size of the area. The code requirement for the reception lobby, reception or lobby area is that it should be set to full on, automatic full on. And then you need a momentary switch to provide the override. I don't think the reception area of a self-storage center would ever fall into the, daylighting zone or a daylight harvesting application. But then again, if it meets those requirements and falls under those applications, then you need to have daylight responsive controls in that area. So if it here, I've assumed that we don't have such requirements. That there isn't much fenestration for that reception, and there is just a door. You come in, and you're being received by the staff there. So you can use the same IS series sensors for this kind of application. IS3360 would be perfect for it. Depending on the size, one or more sensors will cover the whole reception area. Again, I've shown a TR100 here, but then again, since it needs to be automatic all on, you can use a TR100A for this application, which means you would have one less SQ in your bill of material. The other, another important part of the self-storage center is that you have multiple levels, and so you will have staircases. Staircases follow the same requirement as hallways, so you need to have some sensor to automatically turn the lights off. The sensor should be set to automatic all on, and you need a momentary switch to provide manual control. Our recommendation for staircases is actually an ultrasonic sensor, a US one-way, in this case, a US one-way DIM-24. The advantage of having an ultrasonic in a staircase is that as soon as you start turning the door handle, the lights will turn on. So when you open the door completely, the lights are already on, and you don't have to step into a dark staircase and wait for the PIR sensor to see you to turn the lights on. As soon as you open the door, the lights are already turned on, and you can. I mean, in case of a fire emergency, that's perfect. You're not in any kind of risk to your safety that, oh, I have to go in, I'm walking into the dark and I have to take 2 steps before the sensor picks me up and turns the lights on. And why DIM-24? The reason for that is with our new firmware version, you can set the sensor to dim the lights to a lower setting once it stops detecting any occupancy. So you would always have a minimum of, let's say, 20% light in your staircase. So your staircase is always lit, so no one will, again, the combination of having an ultrasonic sensor and not turning the lights all the way off and just keeping them dim to, let's say, 20 or 30%, you're removing any kind of risk to anyone who may need to use the staircase in an emergency. And obviously, you need a power pack to go along with your sensor. Restrooms, we have talked about them before in our education webinar. Same rules apply, pretty much automatic all on, momentary switch, and all that. Depending on the size, there are different solutions for it. I'm just going to go over and tell you about our kind of the worst case scenario, which would be big multi-stall bathroom or restroom, you would need a US Quattro-Com 2-24. This is our recommendation. 2 power packs, one for the lighting, one for the exhaust fan. And the COM 2-24 gives you the option to set different timing levels for the exhaust fans, which we talked about, and a momentary switch to override them. If you have smaller restrooms or just a single, just a small restroom with no stalls, you can just use a wall switch. That would do the trick. So yeah, I mean, the restrooms are something that everyone's familiar with their requirements, and what our solution is from our previous webinars. I don't think there is anything else left for me to explain to you. The most important part of the self-storage center is the storage area aisles and how to deal with them. And now I will hand over to Thurston and let him take care of the rest of the presentation about the data centers.
While Thurston is jumping in, any questions or any comments about storage centers, self-storage facilities, and any of the technology that we're recommending? If not, we can open the phones up at the end as well. But in the meantime, then we can go ahead and turn it over to Thurston.
Very good. Thank you, everyone. Can you hear me now? Hello?
Yes, Thurston, you can hear. Sorry, I was trying to mute everyone else.
Can you see my screen? Very good.
Yeah.
Okay. Data centers. I'm always amazed whenever people send me the designs and have me check them on how much confusion there are of data centers and what they are and how you treat them. Most of the building is office spaces and things like this that we're used to. And then there's some specific areas that are very different for data centers. And that specific areas are the rack areas of it. Here's an overview of the special areas in the data center. You have across the top area here the rack server aisles, and within the rack server aisles there's spaces that they call ballroom space. These are wide open spaces that typically have access for all of the tenants of the space. Many of the server aisles, they're labeled hot aisle, cold aisle, and I'll explain what that is in a moment. Many of those areas are rented out to separate tenants, and those separate spaces are often only separated by, for example, chain link fence. This is not always the way, but it happens pretty common like this. And then you have special areas that are labeled gray areas. These are the areas where you have, for example, your emergency generators, you have your power supply systems, you have switch gear, pump rooms, this type of thing. Those are areas that aren't conducive for use of occupancy sensors in those spaces. Those are spaces that will eliminate from our design with sensor controls. So for our number one spaces that we're going to look at are the hot and the cold aisles. So here's a graphic that represents how this whole thing works. I hope you can see my mouse. What happens is that the hot air comes into the air handlers that are over here on the right-hand side, and these are usually lined up against a whole wall of the server area, sometimes on both sides, sometimes not, but often they're around the perimeter area. The hot air comes in through them, and then quite often it's pushed out then through the bottom. And then it comes up through the bottom, up through some vents in the floor, and then it comes up and it goes through the server racks. The server racks are often passive in nature. In other words, they don't have fans in them. Sometimes, but in many cases, yeah, it's not going to have a fan. It have a fan sometimes with a hot spot that it isolates and it is cooling off. But they're often predominantly passively cooled. Then the cool air goes through the servers, and then it goes into what they call the hot aisle. The hot aisle is sealed off. It usually has plexiglass or something like this that is sealing it off so that you can have the correct pressure to draw the air or push the air both through the server racks. And then the air goes into the cool aisle. The cool aisle is often also sealed, and it'll have access ports at either end often, and those are sealed doors. And so you have to treat both of these areas slightly different in your design because one of the areas is completely sealed off, and the other has the access for people to walk all the way around. The normal people access is always in the cool area, and then the specialty access is within the hot aisles. Here's two pictures, two images, a before and after. So this is a project that we'd worked on, and on the left-hand side, you can see before the server racks are placed in, the way that the air vents are set up on the floor. So often whenever you get a layout, the first time, maybe they just show a room, and in that room, it'll just say data center, server rack. Well, it's impossible for you to do a layout without knowing what the racks are. I often see them, and people will treat it like an open office area or something, and they'll put ultrasonic sensors in there, which is absolutely the worst thing that you could possibly do. It's not an accurate design at all. On the right-hand side, you'll see after they place the server racks. They line the server racks up directly on the edge of where the air ducts are that come up through the floor. And then you can't see it all here, but then there's a piece of plexiglass that runs across the top that makes the air seal. And you can see how the air would flow through those server racks. Okay, so here's an infrared image showing the heat. Okay, there's different types of power supplies. You see there where it says PBU rack. This is a type of rack that is placed on the front, and the power distribution is right there on the front. The sensors can see this. Okay, this is one that's well regulated. You notice the temperature is under 60 degrees. They're typically rated for at least 60 degrees, but you want to keep them cool. So they'll often go through and they have to change the pressure. They have to change the airflow, this type of thing, so that they can keep them at a good functioning level. There's different types of power distribution units too. This is an example of a different type. Whenever we're doing our design, it is somewhat important to realize this, because remember, our infrared sensors are looking for heat, and they're looking for heat in motion, and so all of this airflow and the heat that is being transferred can be seen from our sensors. So in this example, this is what they would call a horizontal type of a rack power distribution unit. And in this case, the cool air comes in, it goes through the servers, and then the power distribution unit is on the back side. So in these, it's somewhat easier to have a good design with your sensor system, because it's not as important that you isolate the coverage only down the aisle and not have it looking at the racks in this type of a setup. Whenever it is the setup where you have the power distribution unit on the front side, it's more important to isolate the coverage to go straight down the aisle. So again, I won't go into this because Priya already explained it, but an infrared sensor is the best solution here, because an ultrasonic sensor projects that sound wave into the space. Well, sound uses air as its medium to transmit through the space. So you can't use an ultrasonic sensor in a space like this because of the massive amount of airflow. The medium of that sound wave is being distorted, and it'll always false trigger. So with an infrared sensor, remember some of the main characteristics here is that it requires direct line of sight to detect, and it gives you the potential, this is one of the most important, gives you the potential to crop that coverage pattern so you can isolate it to that specific aisle. Remember, I mentioned that sometimes these areas are leased out to other people, and there's only a chain link fence. Well, with a passive infrared sensor, you can crop that coverage pattern so it'll just detect people on one side of the fence and not people on the other side of the fence. So those are the main reasons for infrared. The other portion is that it requires a heat source in motion. So it's looking for a warm-blooded person walking down the aisle, moving through that space. Well, all of those servers, all of the racks, all of the power distribution units, these are all creating heat. But because of the airflow, it can be misconstrued sometimes. So that's the reason I showed the two different types of power distribution. Because if you have the strong heat source on the front side, then you need to crop that coverage pattern the best. Whenever we do this, we use our IS-345 sensor. The IS-345 sensor is the perfect solution for these data racks. I've gone in and put our sensors in spaces where competitors had tried to do data centers before and were completely unsuccessful. And here's why. The IS-345-24, well, first of all, it's made to mount either directly to a ceiling tile. It comes with a threaded nipple and a washer and a nut, or you can mount it to an electrical box. It really depends on the way that the data center is designed. Some of them will have a ceiling tile type of construction, but many of them don't. Many of them is an open construction. So you'll drop a box and you'll mount the sensor on a box that's at or just below the fixture height. And then the next image here is whenever you take the lens off of the sensor, then you can see the pyros here. In this sensor, it's specifically designed for the aisleways, and it has two detectors in it. One pyro looks one direction down the aisle and the other the opposite direction down the aisle. And then this lens is also specifically designed for the aisle. You'll notice that part of it is cut away, and that's so that it won't have a view out into the other areas. And then it comes with a shroud. This shroud sits inside underneath the lens, so it's between the lens and the pyro whenever it's mounted. And it comes with this small little triangle cut out. Well, in a data center, it's often that you'll use it just like this, just the way that it comes. So when you have it mounted at about a 9-foot mounting height, it'll see about 15 or 20 foot down that aisle. That's often just about what you need in these aisles, especially whenever they're divided up into smaller sections. But some of them, you need much more coverage. If you have a long aisle and it's not divided up into different tenant sections, this type of thing, then you'll cut a small section out of this. Whenever you cut the small little section, now it'll give you 33 feet of coverage in one direction, and it'll completely cut off the coverage that's back behind it. And then you place the little shroud inside the lens, you reinstall it, and it will only look in that one direction. Additionally, we need to use a power pack of some sort. The power pack has a 20 amp relay that's switching your circuit on and off. We have two basic types, either the TR100, which is the most basic type, or the TR150. Now, the difference being here with the TR150 is that the TR150 has an isolated, normally open and normally closed contact for signaling back to something. So it could be that you want to go back to a building automation system or something like this and let them know that the space is occupied and that the lights have been turned on or brought to high. It's possible that you can also use those contacts to go high-low instead of on-off. The other important thing to note about the TR150 is that it has the capability to have an extra switch connected to it to override the light on, for example, in a space, non-dependent upon occupancy. And that's, I'll show you in a moment the reason for this. Or it could be that you do want to go back to a building automation system or something like this and be able to control the power pack directly. So Now that we know the basics of it, let's look at code and what's important as far as for your design. So in a lot of the country, we're going to follow ICC 2015. And some places now have adopted 2018, and we'll be going in that direction. But nevertheless, throughout most of the country, you would treat this very similar to a warehouse. And so in a warehouse aisle, it's specific in that you will either turn the lights on or off in that specific aisle, or you can go high-low. And the code allows you to reduce the lighting by not less than 50% with using an occupancy sensor. And again, it's important that it's isolated to that particular aisle and you're not controlling any of the lights outside of the aisle. California is slightly different in that they would consider this something that's controlled more like a library stack because it's more similar. The reality of it is, though, the control is the way that the code is written is almost exactly identical to a aisleway for a high bay in ICC 2015 or 2018. Basically, you can turn on, off, or go high-low in those spaces. So one of the other things to consider is ANSI has put out publications that give recommendations of how you should control the lighting in the data center areas. So within the data center areas, they want to make sure that you're placing the lighting above the aisles and not over the cabinets, this type of thing, and that you have the adequate amount of emergency lighting. Of course, this is normal. But they go on to making a different recommendation also. They recommend a 3-level lighting protocol be used in the data center area. So level 1, the data center, when it's unoccupied, they want there to be lighting that should be sufficient to allow effective use of the video surveillance equipment in the space. So this is accomplished in multiple ways, and it depends on the video surveillance. Some of the video surveillance has IR imaging in it. So you'll switch the lights completely off, and then when the space becomes occupied, then they'll go high, and it automatically adjusts for this. Some want you to design it so that there are night lights that are always on. This is very, very common. They'll have the night lights that burn 24 hours a day, 7 days a week, and we're only controlling the other lighting within the space. And then yet others will want you to go high-low within the space instead of on-off. And we can design in all of these ways. It really becomes dependent upon the other equipment that's being used and the preferences of the facility. Level 2 is initial entry into the data center. They recommend that motion sensors should be used to activate lighting in the immediate area of entry and be programmed to illuminate aisles and passageways. Sufficient lighting should be provided to allow safe passage through the space and permit identification via security cameras. So they don't put a specific light level in this level 2. They just say sufficient, okay, for those specific needs. And then they go to level 3. Level 3 is also for occupied spaces. So when the data center is occupied for purposes of maintenance or interaction with equipment, that's the main difference. With the lighting shall be 50 lux, so approximately 50-foot candles, in the horizontal plane and 200 lux in the vertical plane, measured 3 feet above the finished floor in the middle of the aisle. Okay, so the other thing that they offer or they suggest is that you would have an override during that particular situation. So whenever you're doing maintenance on the equipment, this type, or interaction with electric equipment, this type of thing. So we often show how to add an additional switch using a TR-150 so that you can force the lights on in those particular level areas. So here's an overview of what a single level in a data center would look like. On this particular level of the data center, it has predominantly rack aisles, but you also see there are stairwells, there are normal corridors. There's, on the left-hand side, a large open office area. This area is full of cubicles. And one of the things to note, and I'll show it more closely in a moment, but one of the things to note is all of these areas you will control using the sensors like Korea introduced before, but there's always redundant power in the spaces. The redundancy is often even from separate sources, so for separate services. So basically, every other fixture is going to be on a different circuit. There's specific rules that ASHRAE publishes about the way that you would set up an electrical system in the data center. But that's the number one thing for us to note, is that there's redundant services in all of the space. What that means for us is that there's at least 2 power packs, so that if one circuit goes down, that the sensor is still powered and the whole system is still functioning and turning at least one service on/off in space. So here's a little bit closer look of the hot and the cold aisle areas. So in the hot and the cold aisle areas, we treat them slightly differently. Here's an example of a hot aisle area. Within the hot aisle area, we use the IS345-24, and we insert that mask. We insert the mask so that it's only looking into the aisle and does not see any of the motion that's going down the perpendicular mount, or the adjoining aisle here. And then you put a sensor in the middle, because this happens to be a very long one, and then another sensor at the other end. And notice that there's 2 TR150 power packs. Those 150 power packs are used in this case so that we can have an override switch to meet that requirement number 3 of the code. And then this area right here, this is a hot aisle area. You notice it's designed slightly different. The reason being is that there's doors at either end of this aisle, okay? And there's a switch. And we often set this up so that it's manual on functionality in that hot aisle. So somebody opens the door, they step in, sensor sees them, it won't turn the lights on until somebody hits the switch. They hit the switch and then the lights will be on as long as they're occupying that space. And then after they leave, if they fail to switch the lights off, the sensor will time out and turn the lights off for them in that hot aisle. Again, the hot aisle is not used as often and is an isolated area. So note the design difference. Because it's isolated, we have the sensor with a door at either end. We have the sensor, instead of mounted at the very end looking in, we have the sensor mounted over here looking back towards the door. What this does is it gives us the ability to reduce one sensor out of the bill of materials for the same length of aisle. So within the cold and the hot aisles, remember I mentioned that there's often a requirement for an override switch. This is not our first time, so we've done these many times. When you get ready to do one of these projects, please do contact us, because we have all of the diagrams and things needed to set up the forced overrides for maintenance, this type of thing, and happy to help you with it. Again, this is a zoomed up closer version of areas that aren't in the servo space. And the main purpose I wanted to show you here is that within these areas, if it's an office area, if it's a stairwell, if it is a shipping receiving, if it's a bathroom, doesn't matter. All of these spaces are required to have redundancy of those services. So again, really what that means to us is 2 power packs, 1 for each circuit. In some cases, they'll have more than 1 service in the same space. So even if it requires just 1 sensor to control that space, realize that for every circuit, you're going to need a power pack so that you can switch that circuit in that space. And again, whenever you get ready to do one of these projects, we've done many of them, so we have all of the areas already laid out with the correct diagrams, the correct sequence of operation, the correct sensors, so that we can do the entire facility. And in many cases, we'll also interact with other people's controllers of some sort. So maybe if you're integrating with a Crestron or something like this, we have a number of those diagrams already done for integration within the data centers. And I'm happy to help you with them at any time. You can either contact myself or anyone at the technical support office. And we'll open it up for questions for all of the data centers and for Paria's portion of the storage facilities.
We don't have any questions that came in through email or on the chat window. So last chance for some questions or any comments on anything that was presented today.
Well, I did have someone ask me, if this is the same design for every single one of the data centers that we do. And it's not, because technology changes. The other day I had someone contact me and we were looking at the data center, and it turns out that it is one that is submerged in a liquid of some sort. It's a brand new type of a data center. So yes, as things progress with technology, we have to look at the design. We need to look at the way that the power supplies are installed, this type of thing. And feel free to contact us, and we will help you to get the right design for your data center.
All right. Thank you very much, everyone, for attending. We'll have an email sent